Hi, my name is Matt Belton,
I'm Jason Hess.
And I'm Brady Bryant.
and we are Delta Interactive Education. And today we'll be talking about the third design phase for our educational Rube Goldberg machine. First, we will talk about the timeline that we made for our project that we initially made in the first design phase, and how we stumbled upon a few hills, but we were able to complete the project on time. We will also review on what we talked about and what we learned from the first two design phases and how we implemented what we learned in our third design phase. In the third design phase, we will talk about the 3D CAD models and the operation of the BRG, as well as the product architecture, industrial design, and the detailed assembly of our product. We will also talk about the economics of our project, and we will conclude with talking about what we learned from this whole entire process and how we wish to implement what we learned in the future to create the best product possible. As you can see, we went with a linear type of timeline so we could try and focus our attention and our creative minds to just a few projects at one time, so that we could just keep it easier for us and make the best product we possibly could. We initially designed this a certain way, and we hit some roadblocks, and we figured out that the woodworking was a little bit harder than we thought it would be because we were not well versed in that field. So we spent a little bit more time on the woodworking, and we actually adjusted this Gantt chart right here to allow a little bit more time for the woodworking, but we're able to complete other projects at a faster rate so that we're still able to complete our project on time.
So a little bit about DP1 and DP2. These dealt mostly with product planning and generating concepts that provide solutions to our problem of developing the BRG. And as you can see here, we developed a failure modes effects analysis table in which we looked at possible failures for different stations, the causes of these failures, the effects of these failures, and ways we might be able to prevent some of these failures, or at least lessen the severity of these problems.
So the next thing we're going to talk about is the BRG as a whole, how it operates and how it gets the ping pong ball from one end to the other of the pegboard. And so first we'll start with the first station. So to get the ping pong ball to the first station, we simply use an entry ramp which guides it to the bottom here into an elevator cart. The elevator cart is attached to a spring which drapes over a pulley that sits at the top here and attaches to a Arduino servo at the other end. The user inputs some computer code, causes the Arduino servo to start rotating, and winds up the elevator, causing the cart to rise. When it gets to this point of elevation, the ping pong ball exit point, the ping pong ball exits the shaft, but the elevator itself keeps rising, and it hits the bottom of this rotating platform on which a marble sits. It causes the platform to rotate and the marble to fall off and onto the same path that the ping pong ball is taking, which leads to the second station. So the second station is pretty similar to the first in that it has the elevator shaft and a pulley system. So both balls fall into this shaft right here into a cart, which is attached to a pulley system. It is attached to a spring which goes through a series of pulleys, and at the other end sits a counterweight which consists of a small plastic bucket filled with marbles. So the force of the ping pong ball and the marble is enough to make the elevator descend. It descends pretty fast, hits this exit platform right here, which is at an angle, causing both balls to fall out and onto this pathway. This pathway consists of two thin rods which have a pretty big width between them so that the marble falls in between, removed from the equation, but the ping pong ball is big enough so it is guided by these two poles and onto the third station. The third station consists of a series of chutes that the user has to use pinball springs to shoot it through and guide it successfully out of the BRG. So from the second station, the ball enters the third station right here onto this little chute here. The user pulls back the first pinball spring right here and releases it, causing it to shoot up this chute and turn around this corner here, landing in this second chute right here. The user completes the same action as they did just before, only this time if they pull back too far, then the ball will jump over this exit chute right here, which is the objective, and onto this chute, which brings it back to the very first one, and the user has to start the process over again. To reward the user for a successful pullback, the ball gets right here and falls down this chute, but on its way down it hits a platform which rotates and hits another platform, knocking over a marble which is attached to a fishing line, which winds to a series of hooks to a flag. The fishing line is attached to a triangular wedge which keeps the flag at a lowered position and the counterweight up. So after it hits that, the ball goes down this chute and out of the BRG successfully. So next we're going to talk about the product architecture and the individual functions of each station. So the first chunk of 4 that we devised the BRG into is the entry ramp. This serves one purpose, just to get the ball to the bottom of the elevator. The first station has 2 functions. One, to get the ball to an elevated position and release the marble from rest. The second station has 2 functions as well, to get the marble and the ball to a lower position and remove the marble from the equation. And the third station has 2 functions as well. One is to propel the ball through a series of chutes and successfully guide it out of the BRG, and the second is to raise the flag.
So about the industrial design, we wanted a product that was easy to use and accessible by our target market, and we also wanted a product that was smooth transitioning and cohesive between different stations as far as ergonomics go. On the aesthetic side, we wanted to build a product that was smooth and had straight edges, things that were like a city where it's built up in parallel and perpendicular lines to maximize our appeal to our target market.
Next, I'll be talking about the detailed assembly. So when the customer actually receives the product from our company, a lot of the large parts will already be assembled for them, such as the elevator and the ramps. So these ramps come with these square wood pieces attached to them so that they can assemble easily, and that cuts down a lot of time for people to actually assemble it. The only thing besides putting the square slats together that the customer needs to do is just download the code to run the program and set up the Arduino.
As with any product, manufacturing cost is something to consider. A lot of our expenditures were spent on small things, but the larger things were the more essential and more expensive things. We also looked at paying a machinist or possibly a carpenter $15 an hour to design, or rather build the parts that we specify with exact dimensions. We also looked at paying an assembly worker $11 an hour to put together this product in the way we intended to be used.
So the last thing we're going to touch on is the critical assessment we made of ourselves and any future improvements that we learned of. So probably the biggest hindrance of this project was the lack of expertise, namely wood cutting. One part of the BRG, specifically the wedge that holds the flag in place, it didn't stay in its position very well because it was just a triangular piece of wood. If we had a carpenter maybe design a more specific design that was ideal for this, it could stay in its position better and work more successfully. Another thing that was a hindrance was Station 2 pulley system. Sometimes the spring would become misaligned with the shaft, and this would increase the resistance and friction between the 2 planks that made up the shaft and the cart itself. This could result in the cart not even reaching the bottom. So if we could somehow make a rod that fixed the pulleys in place and held the string in the same position, then it can run a lot more smoothly. The next thing that caused us problems was the spring system in Station 3. The second pinball spring, when it was pulled back, sometimes it would get caught on a little piece of wood that was caused by the hole that the nut has to go through, and this would slow the speed of the pinball spring when it was pulled back, so it wouldn't strike the ball with as much force as it could, and the ball wouldn't successfully make it through each chute. And the last problem that we had to dealt with the exit ramp. Sometimes when the ball fell from an elevated position and hit the ground, it would bounce out of the BRG. A solution to this would be to make the walls higher or make a more concise path so that the ball could go through more accurately. And these are the problems that we had making the BRG, and we hope to use the information that we learned here moving forward to make a better and successful product.